Hello, we're going to look at a 3-coin toss. I do apologize for the quality of this video. It's not going to be excellent, I'm sorry, but given the situation, unfortunately, I couldn't think of any other way to do this. Okay, and hopefully you'll get this video. So let's say we have 3 coins, okay? This one, for example, it can be anything. It can be a 1p, 2p, 10 pence, a pound. It can be anything you like. It's just a coin. This can also be any coin, and this can be any coin. We call it unbiased. That means it doesn't matter. The value of the coin doesn't matter. It's just 3 different coins, okay? Or they could be the same coin, 3 of the same, like 3 1 pences or 3 10 pences. That doesn't matter. It's just 3 coins, okay? Now the question says we throw these 3 up in the air at the same time. So we're not just throwing 1 coin up 3 times, we're throwing 3 coins in the air at the same time. Let's make a tree, we call it a tree. Let's write down the tree of possible outcomes, possible events, different ways that these coins can land, and then we're going to look at the probabilities, okay? So coin number 1, I've got my beautiful shiny coin. I toss it in the air, the 3 coins I toss. I'm just looking at number 1 now. I look and it can only either land on its head or its tail. That's it. There are no other ways that a coin can land. Agreed? A coin only has 2 sides. It can either land on its head or its tail. Some of you might say, well, what about the side? It can maybe land on its side. The probability of that is so minimal that we're not going to count that. So just either head or tail, that's all we're looking at. Okay, so I tossed, that's my first coin. Now I'm going to look at my second coin. So this is coin number 2. And they're all on the floor, and I'm going to look at them. Coin number 2, again, can either land on its head or its tail. And in this situation, if coin 1 is on its tail, coin 2 can also either be on its head or its tail, depending on the result of coin number 1. Coin number 2 can be different results. Okay, so if up to now we only had 2 coins, this would be our tree. But we've got 3 coins. We need to look at the results for coin number 3 as well. All 3 of them have been thrown up in the air. They've landed on the ground, and we're looking at the possibilities. We've looked at 1, it can be head or tail. Number 2, depending on what we had before, we have to come up with possible scenarios. Okay. And we're doing the same again for number 3. So this is going to be coin number 3. If previously my second coin landed on its head, if it landed on its head, coin number 3 can either land on its head or its tail. If coin number 2 landed on its tail, this time coin number 3 can either land on its head or its tail. So it is all dependent on what happened before. It's dependent on what happened before. This is how probability works when you've got various numbers, more than one element. Okay, here, the second coin landed on its head. The third coin can either land on its head or its tail. And here, the second coin landed on its tail. The third one can either land on its head or its tail. So first coin landed, it could either land on its head or its tail. The second coin can either land on its head or tail depending on the result of the first one, or it can land on its head or tail depending on the result again of the first one, and the same with the 3. We call this a tree, okay? So now we've got 3. If we had 4 coins, we have another coin here, we would continue the tree for number 4. But for now, we've just got 3 coins. Okay. So now we're going to look at the possible ways and calculate the results that we have. We've got all the possibilities. Now we need to put it down into probability. If coin number 1 landed on its head, That means possibly coin number 2 could land on its head, which means possibly coin number 3 could also land on its head. Okay? Or coin number 1 could land on its head. Coin number 2 could land on its head. Coin number 3 this time could possibly land on its tail. Okay? So that's head, 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 or head, head, tail so far. Now, so we've looked at all of this. Now, we want to look at other options. What about if coin number 1 lands on its head? Coin number 2 this time lands on its tail. Coin number 3 lands on its head. Or what if it's head, tail, tail? Lands on its head, the second one lands on its tail, the third one lands on its tail. So this is the way we've looked up to now, right? So 1, 2, 3, 4. That's if coin number 1 lands on its head. These are all the results. But what if coin number 1 lands on its tail? I'm going to write the results on this side. If coin number 1 lands on its tail, that means according to our calculations, coin number 2 could land on its head, which means coin number 3 could land on its head. Okay? If coin number 1 lands on its tail, that means coin number 2 could possibly again land on its head, but this time coin number 3 could land on its tail. So we've looked at these. Now what if coin number 1 lands on its tail, coin number 2 also lands on its tail, coin number 3 lands on its head? Or, final one, coin number 1 lands on its tail, coin number 2 lands on its tail, coin number 3 lands on its tail, all tails. We have 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. Okay, so now we want to look at the question. The question said you have 3 coins in your hand, you throw them up at the same time. What's the probability of getting tails and heads and also no tails? So tails and heads. I'm looking for outcomes which include tails and heads. Okay, so that's not one of them. There's no tails there. Tails and heads, yes. 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 Tails and heads, no. So altogether we said we had 8. 8 will go down here. 1, 2, 3, 4, 5, 6 is what we have, tails and heads. No tails. So we look here, no tails is only this one. So no tails is 1 out of 8.